Okay, this is problem 4, chapter 10. Make sure I have my calculator, so I'll do some calculation. All right, so a lactic acid lactate ion buffer solution contains 0.27 molarity of, look at the H here. H in front typically means that's the acid, right? And so that's the lactic acid. This right here then is 0.6 molarity. Notice the lack of the H in front and the negative charge. It's that acid that's lost its H plus, isn't it? And so that would be the lactate ion portion of that buffer. Okay, so you have your concentrations of those two, respectively. The Ka value for lactic acid is 1.4 times 10 to the negative 4. Calculate the pH of this buffer. So if you would have read the little thing up top, there is the Henderson-Hasselbalch equation that they drive and give you. And so this is actually the Henderson-Hasselbalch equation right there, okay? By the way, in case you're curious and never looked this up, like I don't remember the Henderson-Hasselbalch, I Google it. You might find two different forms of this. There's this one, of course, which is actually the technically correct one, okay? There's also pH equals pKa minus the log of HA over A minus. Again, you don't really have to write this out or anything. I'm just showing you. These are the same thing, okay? Because when you put a minus in front of a log, that flips the insides, okay? That's like 1 over, right? Okay. So anyways, what we're gonna have to do here is we're just gonna plug these values in. That's it. So remember what a P is though. When you put P in front of something, what does that mean? Well, the P means negative log of, right? So you have a Ka value here. You need a pKa. And so you take the negative log of your Ka, and that gives you your pKa. So our pKa, which we need in that Henderson-Hasselbalch, is going to be the negative log of the 1.4 times 10 to the negative 4th. That's our Ka. And so I would just go ahead and do that first, because that will make your life easier. Don't forget this is log, not ln. Big difference between log base 10 and log natural log, which is log base e. That will change your answer considerably. All right, so negative 4. And if you do this, you find out your pKa equals 3.854. There you go. We plug that value in, so pH, which is what we're looking for, equals 3.854 plus the log of the HA, that would be your weak acid up here, as we put that value in, 0.27, divided by, or whoops, I did the wrong one. I was thinking this, and I did this. All right. I'm gonna rewrite this, because honestly, I just don't have room to do this, where I started it. 3.854, which is pKa, plus the log. And we look up here, it's the A minus over the HA. So the A minus is the one with the minus there. And that's 0.6. We divide that by the 0.127, which is our HA. Again, we know that because it has the H in front and no negative charge. All right, so when we do this, we're going to take that 3.854, we add the log of 0.6 divided by 0.27, and I personally would just do that on my TI-83 Plus or TI-84 or whatever, because I very, very much recommend you just buy for $5 on eBay a TI-83 Plus, like I do. Every time that somebody, actually, mine are from when I was in middle school. So mine are from like 20 years ago. One that I bought. Really? That stinks. Well, if you ask me, I keep one calculator in my bag that I don't normally use, except for when you guys ask me to do prompts. Anyways, I'll write down the answer here. 420, and then it would have been 1. You round it to 3 sig figs, and that's your answer in this case. I can work it for you if you like. If you want to do it on the calculator on like your phone or something, what you would want to do is work this step by step. And so the first thing I would do is work out this right here. And so I would put 0.6 divided by 0.27, which is 2.222, repeating. And so 2.222. All right. Then the next thing you have to do is take the log of that. And so then I would take the log of that. You can switch your computer or phone to scientific. And then you can take the log of 2.222, and that would give you 0.34678. Make sure you always keep a few extra sig figs so that you don't get rounding errors that compound. You're going to take that answer that you got from the log, that's 0.34. You're going to add 3.854, and that would give you your 4.20. Any questions or anybody get lost anywhere? So really you're just following order of operations. So you do the thing in the parentheses first, then you do the log, and then you do the addition, which is always the last thing you do. Assuming it's not in a parentheses somewhere. All right. Let me know if you got that, and I'll stop the video and be good to go. Cool. Okay. Did everybody understand why we did those?